Good morning, students. I am going to begin the module number 5. As I said, after completing the simple mechanisms and the straight line motion mechanisms, I have informed you people that I am going to begin the module number 5, that is gear trains. The topic of the module is gear trains. Let us begin the introduction. What is meant by a gear train? What are the different types of gear trains? And how to find the velocity ratio and a numericals will be solved. Now, beginning with the introduction. So, what is a gear train? So, gear train is a combination of two or more gears meshed with each other to transmit power from one shaft to the another shaft. Suppose if I have two shafts at a certain distance where I want to transfer the power from one shaft to the another shaft. In such cases, the gears will be mounted on the shafts, maybe depending upon the distance, maybe two gears or more gears, so that we can transmit a power from one shaft to the another shaft. So once again, in one sentence, we can understand that gear train is a combination of two or more gears meshed with each other in order to transmit the power from one shaft to the another shaft. So normally a gear train consists of different types of gears, maybe spur gears, helical gears, bevel gears or spiral gears. This gear trains or the gear trains is necessary when it is required to obtain a large speed reduction within a small space. Means whenever we have a small space within which we want to transmit a motion with a large speed reduction, in such cases we prefer a gear train. So generally the nature of gear train depends on the two things. One is how much is the required velocity ratio and what is the relative position of axis of the shafts. So these are the two things based on which one can decide what kind of gear train is suitable in order to transmit the power from one shaft to the another shaft. So what are the two things in order to select a suitable type of gear train? One is how much amount of or how much velocity ratio is required and what is the relative position of axis of the two shafts between which we would like to transmit a power. So normally in general a gear trains are commonly used in various machines, that is lathe, you may say lathe, in lathe machine, drilling machine, milling machine, automobile, in clocks also we can see, in ships and watches. So these are all the applications where we find the gear trains. So with this brief introduction, I can summarize the introduction of the gear train like this. First, the gear train is a combination of two or more gears meshed with each other to transmit a power from one shaft to the another shaft. Second point is, so gear trains will be preferred whenever we need to transmit a power from one shaft to the another shaft where the small space is available and as well as the large production ratio is required. So, and the type of gear train to be selected for a certain application depends on the two things. One is the required velocity ratio, and the second one is the relative position of axis of the shafts. And as I said, I listed the certain applications like lathe machine, drilling, milling machine, automobiles, clocks, watches. In all these applications, we find a gear trains. Now, moving on to the types of gear trains. So, there is one kind of classification. So, depending upon the arrangement of the gears, because I said gear trains consists of different types of gears: spur gear, helical gear, bevel gear, worm wheel, right? Bevel gear. So, depending upon the arrangement of the gears or the wheels, the gear trains are classified into four types. One is simple gear train, second one is compound gear train, third one is reverted gear train, and fourth one is epicyclic gear train. So these are the four types of gear trains which are being classified based on the type of arrangement of the gears. In case of simple gear train, each shaft supports one gear. So that is what the difference, or that is what the point one should remember. So in case of simple gear train, each shaft supporting only one gear, whereas the compound gear train, that is second one, in which each shaft supports two gears except the first and the last. First means it is a driving gear and the last means it is a driven gear. So except the driving and driven gear, so the compound gear train in which each shaft is supporting two gears. Whereas in case of reverted gear train, that is a third type of gear train in which the driving and driven gears are coaxial and coincident. So these are the 3 points one should remember in order to distinguish what type of gear train it is. So first, the gear trains are classified based on the arrangement of the gears. One is simple gear train in which each shaft supports one gear. The second one is compound gear train in which except the driving and the driven, each shaft supports two gears, that is the compound gear. And reverted gear train is the one in which a driving and driven gears are always coaxial and coincident. And one more point is, in the first three types, that is simple gear train, compound gear train, and a reverted gear train. In these three types of gear trains, the axis of the shafts over which the gears are mounted are fixed. So the axis of the shafts over which the gears are mounted, because in a simple gear train, on each shaft one gear will be there. In a compound gear train, so on each shaft two gears will be mounted, or two gears, each shaft is supporting two gears except the driving and driven gear. And in reverted gear train, so the driving and driven gears are coaxial and coincident. So in these three types of gear trains, the axis of the shafts over which the gears are mounted are fixed. And in case of epicyclic gear train, which is the fourth type of gear train, the axis of the shaft on which the gears are mounted may move relative to the fixed axis. So, in case of the first three types of gear trains, the axis of the shaft over which the gears are mounted are fixed relative to each other. So each and every shaft on which the gears are mounted are fixed relative to each other. Whereas in case of last type of gear train, that is in epicyclic gear train, the axis of the shaft over which the gears are mounted may move relative to the fixed axis. So that is what the second difference among the four types of gear trains. So this is about a classification. Now let us understand one by one in detail. So what is a gear train and how to find the velocity ratio in case of each and every type of gear train. So first taking a simple gear train. So what I said in simple gear train, if only one gear is mounted on each shaft and there is no relative motion between the axes of the shafts, then it is called as a simple gear train. Now look at the diagram which I have drawn. So the figure 1, which is a simple gear train, I have drawn the sketches of the three simple gear trains. That is figure 1A. It is a simple gear train, whereas it consists of two shafts over which the two gears are mounted. And in the second figure, figure 1B, it is also a simple gear train in which there are three shafts. On each shaft, the three gears are being mounted. And in the third figure, that is figure 1C, it is also a simple gear train, whereas the four shaft over which the four gears have been mounted, or the four shafts are supporting four gears. So all these three diagrams are known as simple gear train, because if I look at figure 1A, each shaft is supporting only one gear. If I take the second one, once again there are three shafts and each shaft is supporting one gear. Similarly in figure 1C, so there are four shafts and each shaft is supporting only four gears. Here the gears have been represented by means of a pitch circle diameter in the form of a circle. So what is a simple gear train? So if only one gear is mounted on each shaft and there is no relative motion between the axes of the shafts, then it is called as a simple gear train. Now the gears, when the distance between the two shafts is small, when the distance between the two shafts is small, then the two gears, gears 1 and 2, are made to mesh with each other in order to transmit from one shaft to the another shaft, as shown in figure 1A. So now if I look at, whenever I have a space, whenever there is a distance between the two gears, two shafts, between which I would like to transmit a motion, then the two gears are directly made to mesh with each other in order to transmit a shaft from one shaft to the another shaft, which can be seen in figure number 1A. So in figure number 1A, the distance between the two shafts is very small. Therefore, on each shaft, so the two gears have been mounted and made, and directly the two gears, after mounting, they made to mesh with each other so that the transmission of power can take place from one shaft to the another shaft. Since the gear 1 drives the gear 2, if you look at it, the figure 1A, the gear 1, which is named as 1, it is being rotating in a clockwise direction. So the gear 1 is driving the gear 2. Therefore, gear 1 is known as a driver, because there are two shafts and distance between the two shafts is very small. Therefore, the two gears have been mounted separately on each shaft in order to transmit a power from one shaft to the another shaft. Now, there are two gears which are being represented by their pitch circles in the form of a circle, named as 1 and 2. Inside, I have put the arrow mark showing in what direction the two gears are being rotating. So the gear 1 drives the gear 2, because if I rotate the gear 1 in a clockwise direction, the another gear, with the help of gear 1, the gear 2 will drives. So therefore, gear 1 is known as a driver, and the gear 2 is known as a driven gear, or it is simply called as a follower. So therefore gear 1 is the driver and gear 2 is called as a driven or a follower. And one more thing which we must keep it in mind, that in what direction the driver is rotating. Here the driver is rotating in a clockwise direction, right? So as a result, it drives the driven in the opposite direction, means the driven gear or the follower rotates in an anti-clockwise direction. Therefore, so the 3 points totally one should remember from the figure number 1A. So figure number 1A is a simple gear train. It consists of 2 shafts, and each shaft each shaft is supporting 1 gear. So 2 shafts and each shaft is supporting one gear. So the 2 gears are named as 1 and 2, which can be seen in the figure, and the gear 1 is driving the gear 2, or gear 1 drives the gear 2. Therefore, the gear 1 is known as a driver and the gear 2 is known as a driven or a follower. Means gear 2, how it is rotating, it is being driven by a gear 1. So therefore, gear 1 is called a driver and gear 2 is called as a driven or a follower. But this type of arrangement of a simple gear train will be preferred or will be used whenever the power is to be transmitted between the 2 shafts where the space available is very small. So the points to be remembered from this figure 1A is it is a simple gear train, and the second one, it consists of 2 gears which are directly meshed in order to transmit a motion from one shaft to another shaft, as there is a small space which is available between the 2 shafts. So, and gear 1 is known as a driver and gear 2 is called as a driven gear or a follower. And in what direction the driver is rotating, in the opposite direction the driven or the follower will be rotating. So always the direction of rotation of the driver and the driven will be opposite to each other. So this is the point 1 I should remember. Suppose if I rotate the driver in a clockwise as it is shown in the figure 1A, so the driven will be rotating in anti-clockwise. So instead, if I rotate the driver in a anti-clockwise, then the driven or the follower will be rotating in clockwise direction. Therefore, so one of the point which should be remembered very important as a part of numericals which we are going to solve later on. So in what direction the driver is rotating, in the opposite direction a driven or the follower is rotating. Therefore, so the motion of the driving and the driven gear is opposite to each other. Now let us take, because our objective here, not only we have to understand how the gear train is working. So because our motto is because I said gear train is depending on, gear train will be selected in order to transmit a power from one shaft to another shaft based on the 2 things. One is how much is the required velocity for us, and what is the relative position of axis of the shaft. Here I have explained in detail how the gear train and how many shafts it contains, in what way they are mounted, and the gears and each shaft is supporting how many gears. That is all being discussed. So only one important thing, which is in case of any type of gear train, as I said, how much required velocity ratio. So our objective here, after understanding so how to find the velocity ratio. So in order to find the velocity ratio, let us take, now I am explaining the figure 1A with which how to find the velocity ratio. Let N1 is the speed of the gear 1 or a driver in so many revolutions per minute. So Please understand, here I am finding the velocity ratio. It is also called as a speed ratio, or it is also called as a gear ratio. Velocity ratio or gear ratio or speed ratio. All these three are same. Now how to find the velocity ratio? To find the velocity ratio in case of this simple gear train, let us take N1 is the speed of the gear 1 or a driver in RPM, that is revolutions per minute, and N2 is the speed of the driven gear or a follower in RPM. And let us take T1 is the number of teeth on gear 1 and T2 is the number of teeth on gear 2. Now what I want here? I want a speed ratio or a velocity ratio of a gear train. So what is meant by a velocity ratio or a speed ratio in case of a gear train? So it's not a simple gear train or it is not a compound gear. So in general, theoretically, how the velocity ratio can be defined? So the velocity ratio or the speed ratio of a gear train is the ratio of the speed of the driver to the speed of the driven. So what is the velocity ratio or speed ratio? It is nothing but the ratio of speed of the driver to the speed of the driven. This ratio is called velocity ratio, and that is equal to what? The ratio of reciprocal of their number of teeth. You please understand the meaning of velocity ratio. First, what are the three different synonyms I told? Velocity ratio or gear ratio or speed ratio. Now in general, what is meant by a velocity ratio or a speed ratio? It is the ratio of speed of the driver to the speed of the driven, which is equal to the ratio of reciprocal of the number of teeth. Reciprocal of their number of teeth. Now, what is the speed of the driver? I took speed of the driver is nothing but N1. And what is the speed of the driven? That is N2. So, therefore, velocity ratio or speed ratio is equal to speed of the driver, that is N1, by speed of the driven or follower, that is N2. So, therefore, N1 by N2 is equal to ratio of reciprocal of their number of teeth. Reciprocal, strictly speaking, it is T1 by T2. But the velocity ratio N1 by N2 is equal to reciprocal of T1 by T2. That is nothing but T2 by T1. Which in turn, in terms of pitch circle diameter of a gear, one can write D2 by D1. So this is the formula to find the velocity ratio or speed ratio of a gear train. So speed ratio or velocity ratio is equal to speed of the driver, that is N1, by speed of the driven, that is N2. So N1 by N2 mathematically, that is equal to reciprocal of their number of teeth. So reciprocal 1 2 is nothing but 2 1. Therefore that is equal to T2 by T1. So number of teeth on driven is T2 and the number of teeth on the driver is equal to T1. That is equal to, if I know the pitch circle diameter of the gear which is mounted on the gears, so one can write N1 by N2 is equal to, not only it is T2 by T1, that is equal to D2 by D1, where D2 is the pitch circle diameter, in short PCD, pitch circle diameter of gear 2 by pitch circle diameter of gear 1. So like that one can find a velocity ratio or a speed ratio. Further, one more important word is train value. So train means gear train. So train value of a gear train is defined as the reciprocal of a velocity ratio. What is a velocity ratio? N1 by N2, because it is the ratio of the speed of the driver to the speed of the driven, or ratio of speed of the gear 1 to the speed of the gear 2, because gear 1 is a driver, gear 2 is a driven. So therefore velocity ratio is N1 by N2. So therefore, but now what I want to define is a word called train value. So train value of a gear train is defined as what? Train value is equal to reciprocal of velocity ratio. What is velocity ratio? N1 by N2. If I take the reciprocal, it is N2 by N1. Therefore, N2 by N1 is known as a train value. When there is N2 by N1, then it will be T1 by T2. Not here Z1 by Z2. It is T1 by T2. That is equal to D1 by D2. Like that, two things which I can calculate for a gear train. If I want velocity ratio, it is the ratio of speed of the driver to the speed of the driven. That is equal to N1 by N2, which is equal to the reciprocal of the number of T's. That is T2 by T1, which is equal to, in terms of pitch circle diameter, D2 by D1. Similarly, the second thing which I can also calculate if I am interested, that is a train value. So train value is the reciprocal of the speed ratio. Therefore, train value is equal to 1 upon velocity ratio, that is equal to 1 upon N1 by N2. So then it will be N2 by N1, which is equal to T1 by T2. I am sorry here, not Z1 by Z2, it is T1 by T2, that is equal to D1 by D2. Like that, two things can be calculated. But now look at, if I extend further, the distance between the two gears is large. Means when the distance between the driver and the driven is too large, in such situations, the transmission of motion from one gear to the another gear can be transmitted by means of two ways. Because now what we have discussed with respect to figure 1a, the distance between the two shafts are very small. Therefore, directly on each shaft, I mounted two gears and made direct meshing in order to transmit a power from one shaft to the another shaft. Instead of a small distance between the two shafts, suppose if I have a distance between the two gears of the two shafts is too large, then in such situations, one can transmit a motion in between the two gears or in between the two shafts by means of two ways. One is by providing large sized gear. So, sir, if the distance between the two shafts is too large, then let us take two gears and let us make the two gears in contact, in mesh. We will mesh the two gears. We will make the big size of gears. That is what here you people may think. But whenever the distance between the two shafts between which the motion is to be transmitted or power is to be transmitted is too large, in such cases, here, though there is a way, what is that? By providing a large sized gear. So, let us take the two gears, sir. So, driver and driven, both gears, we will make it big size so that we can transmit directly. So, instead of directly as we discussed in the earlier case. No, one cannot do that. So whenever the distance between the two gears or the two shafts is too large, in such cases, so one way is by providing a large sized gear. So if I do so, if I make the driver and driven of bigger size, then it may not be inconvenient and moreover uneconomical. So therefore, the second way is we can provide one or more intermediate gears. So instead of making the driver and driven of bigger size, whenever the distance between the two shafts are too large, in such cases we will provide one or more intermediate gears. So by providing how many, it may be required one intermediate gear or it may be more than one intermediate gear. That depends upon how much is the gap in between the two shafts. in between the two shafts. So, but if I adopt the second way, it is convenient and economical. So therefore, so whenever the distance between the two shafts between which the motion is to be transmitted, then only two gears are enough. If the distance between the two shafts is too large, in such cases, in addition to the driver and driven in between, so we will use one or more than one gears where they are called as intermediate gears. So when the number of intermediate gears are odd, suppose in between the driver and driven, if I look at the figure number 1b, so in between the driver and driven, so there is one intermediate gear. So then intermediate gear is 1, which is an odd number. So whenever the number of intermediate gears are odd, maybe 1 or maybe 3 or maybe 5, 7 and so on. So then the motion of both the gears, that is driver and driven, is like, means in what direction the driver is rotating, in the same direction driven or the follower is rotating. So which can be clearly seen in the figure number 1b. Right? Because in between the driver and the driven, so the distance is large, so I have provided one intermediate gear. So 1 is an odd number. So like that, if the number of intermediate gears in between driver and driven is a odd 1, 3, 5, 7 and so on, then the motion of the driver and the motion of the driven or the follower is like. Like means in the same direction both are rotating, which can be seen clearly in figure number 1b. Similarly, suppose if the distance is too large, sometimes maybe instead of 1, 2. Now that can be seen in figure number 1c. So in figure number 1c, so what happens? So there are two gears, intermediate gears. So apart from driver and driven, in between, to bridge the gap, the two intermediate gears are used. So 2 is a even number. So therefore, so whenever the number of intermediate gears or even number, means in figure number 1c, 2 intermediate gears are there, 2, 4, 6, 8 and so on. So then the motion of the driven or the follower will be in the opposite direction of the driver. See, the driven or the follower is rotating in anti-clockwise direction, whereas the driver is rotating in clockwise direction. So the direction of the driver and the driven is opposite to each other whenever the number of intermediate gears in between a driver and a driven is even number 2, 4, 6 and 8. Whereas when the number of intermediate gears are odd number, that is 1 or maybe 3, 5. So whenever the number of intermediate gears are odd number, so then the direction of the driver and the driven will be same, will be in the same direction. Both will be rotating in the same direction. So now for the figure number 1b, if I take the figure number 1b, so for how to find a velocity ratio of a simple gear train in which there is a one intermediate gear. So one intermediate gear, that is figure number 1b. So for the figure number 1b, let us take, let N1, because here how many shafts are there? 3 shafts. On each shaft there are 3 gears. One is a driver, that is a gear 1. The other one is a driven or the follower, which is nothing but gear 3. In between a driver and a driven, there is one intermediate gear which is named as 2. Now see, in the figure number 1b, the driver is rotating clockwise. This drives the gear 2, thereby the gear 2 is rotating in anti-clockwise. This gear 2 in turn drives the driven gear. So that driven gear is rotating in clockwise. So therefore, now let us take with respect to the figure number 1b. Right. So let N1 be the speed of the driver in revolutions per minute. N2 is the speed of the intermediate gear in revolutions per minute, and N3 is the speed of the driven in revolutions per minute. Similarly, let us take T1 is the number of T's on the driver, T2 is the number of T's on the intermediate gear, and T3 is the number of T's on the driven or the follower. Now, how to find a velocity ratio or a follower, how to find the velocity ratio or a speed ratio for this figure, that is figure number 1b. Now, how to start, how to find? So, in case of only two gears, directly N1 by N2 is equal to T2 by T1. But here, in between the two gears, that is driver and driven, there is a one more intermediate gear. So in order to find the velocity ratio, I took N1, N2, N3 or the speeds of the driver, intermediate gear and driven in so many revolutions per minute. And T1, T2, T3 are the number of T's on driver, intermediate gear and driven gear. Now to find the velocity ratio, right, first how I should begin. Here gear 1 is in contact with gear 2. So driving gear is in mesh with the intermediate gear. Therefore, the velocity ratio between the gear 1 and gear 2 should be calculated first. That is equal to N1 by N2 is equal to reciprocal of the T's, number of T's on the two gears. So N1 by N2 is equal to T2 by T1. So this is the velocity ratio in between the gears 1 and 2. Because how I can say? Because gear 1 is driving the gear 2 and both are in mesh with each other. Therefore, velocity ratio between the gears 1 and 2 is equal to mathematically N1 by N2, that is speed of the gear 1 by speed of the gear 2. N1 by N2 is the velocity ratio, that is equal to ratio of reciprocal of their T's. Here that is equal to T2 by T1. So this is the velocity ratio between the gears 1 and 2 because they are directly in contact with each other or they are directly meshed with each other, and gear 1 is driving the gear 2. Therefore, N1 by N2 is equal to T2 by T1. Similarly, gear 2 in turn is meshing with the gear 3. So means gear 2 is driving the gear 3. So therefore, once again I can find one more time a velocity ratio between the gears 2 and 3 as they are meshed with each other. So according to the definition, the velocity ratio between the gears 2 and 3, that is equal to N2 by N3 is equal to T3 by T2, reciprocal. So here I am finding 1, 2. When I am finding in between the gears 1 and 2, so N1 by N2 is equal to reciprocal of their T's, that is T2 by T1. That is what I got, equation number 1. Similarly, in between 2, 3, as they are indirectly meshed with each other, so 2, 3, how to write the velocity ratio? N2 by N3 is equal to ratio of reciprocal of their T's, that is T3 by T2. Now this you call it as 2. So N1 by N2 is equal to T2 by T1. That is equation number 1. What is that equation number? It is the velocity ratio between the gears 1 and 2. Similarly, equation 2, that is the velocity ratio between the gears 2 and 3. Like that separately you find. Now find the speed ratio or the velocity ratio of the whole simple gear train. So that can be obtained by multiplying the equations 1 and 2. So then I can get for the whole gear train. That is for the figure number 1b. So if I multiply equations 1 and 2, what is the left hand side? N1 by N2. of equation 1, and what is the left hand side of the equation 2? N2 by N3. If I multiply both, so N1 by N2 into N2 by N3. These two are the left hand side of equation 1 and equation 2. Therefore, N1 by N2 into N2 by N3 is equal to, I am multiplying left hand side of equation 1 with the left hand side of equation 2. Similarly, multiply the right hand side of the equation 1, that is T2 by T1, with the right hand side of the equation 2, that is T3 by T2. So now, if I multiply both the equations, left hand to left hand, right hand side to right hand, so then N2 gets cancelled, then I will be left with N1 by N3, that is equal to, here T2 gets cancelled, T3 by T1. Now this equation shows the speed ratio or the velocity ratio in case of a simple gear train whenever there is one intermediate gear in between the driver and the driven. In between the driver and the driven. Now if I write it N1, what is N1? It is the speed of the driver by speed of the driven, that is N3. So therefore N1 by N3 is said to be a velocity ratio, because in figure number 1b, which is a driver gear? Gear 1. Which is a driven or follower? That is gear 3. So what is velocity ratio? Speed of the driver to the speed of the driven always. Therefore N1 by N3 is nothing but the speed of the driver or the gear 1 to the speed of the driven or the gear 3. That is equal to number of teeths on the driven, that is T3, by number of teeths on the driver, that is T1. So this is the velocity ratio for a simple gear train whenever there is only one intermediate gear. Like that, I can find directly the velocity ratio for any number of intermediate gears in between the driver and the driven. Now, for example, if I take figure number 1C, in figure number 1C, gear 1 is a driver, gear 4 is a driven, where I would like to transmit a motion in between these two shafts, 1 and 4. In between there is a gap, and I have provided how many intermediate gears? 2 gears. Gear 2 and gear 3 are intermediate gears. Now when any number of intermediate gears, always the speed ratio or gear ratio or velocity ratio in case of a gear train is equal to speed of the driver, that is N1, by speed of the driven, that is N4. So here driver is gear 1, driven is gear 4. So what is velocity ratio? That is equal to speed of the driver, that is N1, by speed of the driven, that is N4. So N1 by N4 is equal to ratio of reciprocal of their teeths, that is reciprocal of their teeths, that is equal to number of teeths on the driven. Number of teeths on the driven is nothing but T4, and number of teeths on the driver is equal to T1. So directly you need not to calculate separately and multiply and to find the velocity ratio for any number of intermediate gears in between a driver and a driven. One can write directly a velocity ratio formula like this: N1 by N4 is equal to T4 by T1. So with the above discussion, one can summarize that this equation holds good even if there are any number of intermediate gears. That is what I told. Suppose if I take the simple gear train, instead of 2, I will provide 3. Then the driver will be 1, driven will be 5. So then N1 by N5 is equal to T5 by T1. Like that, for any number of intermediate gears in between the driver and the driven, this equation holds good. So and one more thing, speed ratio or the velocity ratio is independent of size. So here whether the size of the driver and the driven both are same or they are different, or the size of the intermediate gear is equal to the size of the driver or the driven. So irrespective of the size of the gears, so one can able to find the velocity ratio. Therefore, so velocity ratio is independent of size. I am not worried what size of, how much is the size of the gear, right? And similarly, so number of intermediate gears also I am not worried, because so that is simply the intermediate gears or does not affect on the velocity ratio, because if you look at figure number 1b, velocity ratio is n1 by n3 is equal to t3 by t1. Similarly, if I take figure number 1c, so here there are two intermediate gears, but what is the velocity ratio? n1 by n4, always driver by driven is equal to driven by driver. So n1 by n4 is equal to t4 by t1. So therefore it is independent of size, velocity ratio is independent of size, and also non-independent of number of intermediate gears. It does not depend upon how many intermediate gears are there. Therefore, these intermediate gears are called as specifically ideal gears. Ideal gears. Now, for example, if I take my fourth section D, there are so many people, 79 as on the roll. So out of 79, so all 79 will not be active when I am explaining. So few are least bothered, few are neglected. Okay, it is his duty, let him do a lecture. So, and without bothering, without showing some respect and concern, so always they do their own business. They just keep on going there, doing their personal activities. So intermediate gears are called as ideal gears. They are not going to affect, because they are out of 79, if 5 and 6 such kind of students fail in the subject, so based on that I may not be gauged that whether I am a good teacher or a bad teacher. So it doesn't affect it. So those such some 5-6 students will not affect the entire system of teaching learning activity. So therefore, intermediate gears or ideal gears, they did not take active part in the power transmission. So because they are simply provided in order to bridge the gap in between the driver and the driven. Therefore, intermediate gears are specifically called as ideal gears. So the ideal gears, one should remember, the ideal gears are used for two purposes. One is to connect gears where a large center distance is required. So whenever the distance between the two gears is too large, in such cases, in order to connect the driver and the driven, ideal gears are used. And similarly, to obtain the desired direction of motion of the driven gear. Suppose not only if I am interested in finding the velocity ratio, in what direction while transmitting a power, I am also particularly interested in what direction the driven or the follower is to be rotated. If I want to rotate it in the same direction or in the opposite direction of the follower. So based on that, if I want to rotate the driven or the follower in the same direction of the driver, then I'll go for the odd number of intermediate gears or the ideal gears in between the driver and the driven. Suppose if I want to rotate the motion of the driven gear in the opposite direction of the driver, then I will provide the number of intermediate or the ideal gears will be equal to even 2, 4, 6 and so on. So therefore, the main two purposes for which the ideal gears are being used in case of a gear train are, one is in order to connect the two gears, that is driver and the driven, whenever there is a large center distance is required. And second, to obtain the desired direction, whether I want the direction of motion of the driven gear in the same direction of the follower driver, or if I want the direction of motion of the driven gear in the opposite direction of the driver. So depend, for that also one can use the ideal gears. So this is all about the in detail explanation of a simple gear train. Simple gear train. Now we will go on to the second type of gear train, that is compound gear train. So the second type of gear train is a compound gear train. So if there are more than one gear on a shaft except first, that is driver, and last, that is driven, then it is called as a compound gear train. Because I said very clearly that in case of simple gear train, each shaft is supporting one gear. Right. So in case of compound gear train, except the driver and the driven, if the gear train in which each shaft is supporting more than one gear, then it is called as a compound. Now look at the figure. In the figure 2, which shows the diagram of a compound gear train. Here the first one is a driver and the last one is a driven. Except these two, in the top view we can see in between the driver and the driven there are two gears. And these two gears are mounted on the shaft B. Gear 2 and gear 3 both are mounted on the shaft B, that can be seen in the top view. Similarly, gear 4 and gear 5 is mounted on only one shaft, so that is the shaft C. But you see, first shaft only it is supporting one gear, that is gear 1. Gear 1 is mounted only one gear, that is gear 1 is mounted on shaft A, whereas the gear 6 is the only one which is mounted on one separate shaft, that is shaft D. But in between gear 1 and gear 6, which are said to be driver and driven, there are two sets of gears, that is gear 2 and gear 3. Gear 2 and gear 3 both are mounted on only one shaft, that is on shaft B. And the gear 4 and gear 5 both are mounted on the shaft C. Therefore, here 2, 3 is mounted on one shaft and 4, 5 is mounted on one more shaft. So the shaft B and shaft C are carrying more than one gear, except the shaft A and shaft B, which carries only one gears each. Therefore, it is said to be a compound gear train. Whenever the distance between the driver and the driven has to be bridged over by intermediate gears, not only our objective, because I said in simple gear train, the distance between the driver and the driven will be filled or will be bridged. That gap, whatever is there, will be bridged by means of intermediate gears, because it doesn't affect the velocity ratio. Therefore, but however, when the distance between the driver and the driven has to be bridged over by means of intermediate gears, not only our objective to be fulfill the gap which is existing in between the driver and the driven with the help of intermediate gears, at the same time a great velocity ratio is required. Then the advantage of ideal or intermediate gears is intensified by providing a compound gears. By providing a compound gears on the intermediate shaft, we will go for this kind of a gear train. So, have you understood? In simple gear train, what we did in figure number 1b and 1c, we have bridged the gap in between the driver and the driven by means of one gear in figure number 1b, by means of two gears, intermediate gears in between driver and driven in figure number 1c. But not only our objective is to fill the gap in between the driver and the driven by means of intermediate gear. At the same time, we have to see that a greater velocity ratio is required, because mainly the type of gear train which we select is depending mainly on the velocity ratio. Therefore, not only our objective is to fill the gap in between the driver and the driven for the power transmission. So there should be an objective that greater velocity ratio is also required. So in that cases, the intermediate shafts in figure 2, what are the intermediate shafts? Shaft B and shaft C. Or intermediate gears are being intensified by providing a compound gears. Therefore, 2 and 3 are called compound gears, 4 and 5 are also said to be compound gears. So, in order to achieve the highest velocity ratio, the intermediate gears are being intensified by providing a compound gears on the intermediate shafts. Figure number 2, which shows, I said, it is a compound gear train in which each intermediate shaft has two gears rigidly fixed to it so that they may have the same speed. So 2, 3 is mounted on the shaft B so that they are fixed rigidly to each other, so that whenever the 2 rotates, 3 is also rotating at the same speed. Similarly, 4 or 5 are rigidly mounted on the intermediate shaft C. The gear 1 is a driving gear mounted on the shaft A, as I said already. Gear 2 and gear 3 are said to be compound gears which are mounted on the shaft B. And gear 4 and gear 5 mounted are said to be also a compound gears. They are mounted on the shaft C. And the gear 6 is mounted on the shaft D. So, how to find now the velocity ratio in case of a compound gear train? Now let us consider N1 is the speed of the driving driver or the gear 1. T1 is the number of T's on the driving gear 1. Like that, N2, N3, N4, N5, N6 are the speed of the respective gears 2, 3, 4, 5 and 6 in so many revolutions per minute. T2, T3, T4, T5, T6 are the number of T's on the gears 2, 3, 4, 5 and 6. Now first of all, if I look at the diagram, gear 1 is meshing with gear 2. Therefore, one can find the velocity ratio is equal to what? In between the gears 1 and 2, N1 by N2 is equal to T2 by T1. That you call it as 1. Because gear 1, which is a driver, is in mesh with gear 2. So therefore, in between gear 1 and 2, what is the velocity ratio? That is N1 by N2 is equal to opposite T2 by T1. That is the velocity ratio of gears in between 1 and 2. Similarly, next, in what direction the gear 2 is rotating, gear 3 is also rotating in the same direction with the same speed, because 2, 3 is a compound gear. So this gear 3 is in mesh with gear 4. Therefore, 3 and 4, between which the speed ratio or the velocity ratio is equal to 3, 4, means N3 by N4 is equal to reverse. T4 by T3. That is the velocity ratio between the gears 3 and 4. Now when the gear 4 rotates in a clockwise direction, the gear 5 is also rotating in the same direction with the same speed, as both are mounted on the same shaft. So then once the gear 5 rotates, which in turn that rotates the gear 6. So therefore gear 5 is driving the gear 6. So in between 5 and 6 gears, the velocity ratio is equal to N5 by N6 is equal to T6 by T5. That you call it as 3. Now understood? One is driving, gear 1 is driving the gear 2. So in between gear 1 and gear 2, the velocity ratio is 1, 2, means N1 by N2 is equal to T2 by T1. Next, when gear 2 rotates, gear 3 simultaneously rotates in the same direction with the same speed as 2, 3 are mounted on the shaft B. So when gear 3 rotates, it drives the gear 4. Therefore, gear 3 is driving the gear 4. So therefore, in between 3 and 4, so the velocity ratio is N3 by N4. 3, 4, I am saying 3, 4 means N3 by N4 is equal to reverse T4 by T3. Similarly, when the 4 rotates, gear 5 is also rotating in the same direction and with the same speed. When gear 5 rotates, it drives the gear 6. Therefore, gear 5 is driving the gear 6. So, in between 5 and 6, the velocity ratio or speed ratio is equal to 5, 6. So, 5 and 6 means in between 5, 6 I want velocity ratio. So, N5 by N6 is equal to T6 by T5, reciprocal of the number of T's. Always speed. You remember 1, 2 means speed is N1 by N2. That is equal to reciprocal of the T's, means T2 by T1. Similarly, in the second equation, this is the velocity ratio in between 3, 4. That is why I wrote it N3 by N4, which is equal to reciprocal of the number of T's on gear 4 and gear 3. Therefore, I wrote T4 by T3. Like that, separately, you find the velocity ratio, and to get the velocity ratio for the whole compound gear train, you multiply totally now 3 equations. Equation 1, 2, 3. Now, left hand side of equation 1 is N1 by N2 into left hand side of equation 2 is N3 by N4 into left hand side of equation 3 is N5 by N6. Like that, you multiply the left hand side of equation 1, equation 2, equation 3. That is N1 by N2 into N3 by N4 into N5 by N6. That is equal to multiply the right hand side of the 3 equations. T2 by T1 into T4 by T3 into T6 by T5. Now, here N2 is equal to N3 because gear 2 and gear 3 are compound gears and both are mounted on the same shaft. So, because the speed of the gear 2 will be gear 3, therefore N2 is equal to N3. So, these two gets cancelled. Similarly, N4, N5, speeds of gear 4 and gear 5 same, because gear 4 and gear 5 are compound gears mounted on the same shaft. Therefore, speed of the gear 4 will be equal to the gear 5. So, N4 is equal to N5. So, hence N2 is equal to N3. These two gets cancelled. N4 is equal to N5. Therefore, these two gets cancelled. Only I left on the left hand side is equal to N1 by N6. That is equal to T2 into T4 into T6 by T1 into T3 into T5. Now, with this I can write in general the velocity ratio in case of a compound gear train is equal to, what is N1? It is the speed of the gear 1. In the figure gear 1, what is gear 1 is called? It is a driver. Therefore, speed of the first driver by speed of the last driven is equal to product of number of T's on the drivens by product of number of T's on the driver. Because look at the gear 1 is driving the gear 2. Next, gear 3 is driving the gear 4. Next, gear 5 is driving the gear 6. Therefore, N1 is what? It is the speed of the first driver, and N6 is the speed of the last driven. That is equal to, how to find the velocity ratio? Velocity ratio is very clear. Speed of the driver by speed of the driven. N1 by N6. That is equal to, in case of compound gear train, product of number of teeth on drivens. Gear 2 is driving gear 1 is driving gear 2. Therefore, 2 is called driven whenever I am finding the velocity ratio between 1 and 2. Similarly, gear 3 is driving gear 4. Therefore, in between 2 and 4, 4 is called a driven. Next, similarly, so when I am finding a velocity ratio in between 5 and 6, 5 is driving the gear 6. Therefore, 2, 4, 6 are called drivens. So, therefore, product of number of T's on drivens. Here, this is anyhow driven wheel is 1, but in between there are 2 driven, 2, 4. Because 2 is said to be a driven gear when gear 1 is a driver, and while finding the velocity ratio in between 1 and 2. When I am finding velocity ratio in between 3 and 4, gear 3 is called a driver, gear 4 is a driven. When I am finding the velocity ratio between 5 and 6, 5 is called a driver and 6 is called a driven. So like that, in between the first driver and the last driven, there are 2 drivers and 2 drivens. Therefore, product of number of T's on the driven, 2, 4, 6 are called driven gears, and 3, 1, 3, 5 are called drivers, because 1 is driving gear 3 and gear 3 is driving the gear 4 and gear 5 is driving the gear 6. Therefore, 1, 3, 5 is called drivers and 2, 4, 6 are being driven by 1, 3, 5. Therefore, they are called the drivens. So like that, so N1 by N6 is the velocity ratio, that is equal to speed of the first driver to the last driver is equal to product of number of T's on the drivens by product of number of T's on the driver. So the advantage of compound train is that the much larger speed reduction from the first shaft to the last shaft can be obtained with a small gears compared to the simple gear train. So if a simple gear train is used to give a large speed reduction, so the last gear has to be very large. But generally, for a speed reduction in excess of 7 to 1, a simple gear train is not used, but a compound gear train is used. So this is about a compound gear train. Now I am concluding by summarizing the class. So in the next class, I am going to solve some numericals which are connected to the compound gear train. So now in the today's class, so what are all the things we have discussed? What is gear train, and for what purpose the gear train is being used, and what are the applications where we find the gear trains. Then how the gear trains are being classified. So there are 4 types: simple gear train, compound gear train, reverter gear train and epicyclic gear train. Out of these 4 today, so we have just discussed about the first 2 types of gear trains. One is simple gear train and another one is a compound gear train. So what is simple gear train and how to find the velocity ratio, and in between the 2 gears, whenever the distance is too large, so we are using the intermediate gears, which are specifically called as the ideal gears. So whenever the number of ideal gears are odd, so what is the direction of motion of driver and the driven? Similarly, whenever the number of intermediate gears or the ideal gears are even in between the driver and the driven, then what is the direction of rotation, and what is the purpose of using the ideal gear or the intermediate gear, and also how to find the velocity ratio. Then again in the next class, so I am going to summarize it by recalling how to find the velocity ratio in case of simple gear train whenever it is having only two gears, whenever it is having one gear in between two driver and the driven. So whenever the number of intermediate gears are even, like 2, 4, 6 in between driver and the driven, how to find the velocity ratio, and also how to find the velocity ratio in case of compound gear. Again, 1/2 hour I will have some tips to remember how to find the velocity ratio very easily in a fraction of seconds without any confusion, and then later I will solve some simple problems. Okay, so thank you friends.